Hi y'all. Part 2 of the video because Miss Avra forgot her formula sheet and then couldn't remember how to do this. So welcome back. I haven't had my full cup of coffee in the morning quite yet, so I'm not fully here. But we're going to calculate some percent error. Okay, so we have two values in percent error. We have our A value, which is our approximated value, and then VE, or our exact value. Okay, so we've got our approximate minus our exact to calculate error. To calculate percent error, we do our approximate minus our exact divided by the exact times 100 to convert it to a percent. So here I'll write the formula again over here. Our approximate minus our exact divided by our exact times 100 to get it to that percentage. Okay? So it says Sonia expected to get $60 for her birthday. Okay, if she expected, that's going to be the approximate value. But she only actually got 40. So that is our actual value. What is the percent error? So from there, we're just going to plug in. Our actual is 40. So I'm going to do 40 minus, our exact. We start with our approximate, which is 60. Sorry. So I do 60, my approximate, minus my exact of 40. All of that over my exact, which is 40, times 100. And this you can plug straight into your calculator as long as you use that fraction bar. So I've got 60 minus 40 over 40 times 100. And that's going to give me 50%. $60 minus 40 divided by 40. So our approximate minus our exact divided by our exact times 100. Sorry, y'all, I think the video cut out there for a minute. We back? Okay, I think we're back. Sorry about that. Struggling with technology this morning. So we should end up with 50%. Okay? This next one, it says Jamal needs to purchase a countertop in his kitchen. Jamal measured the countertop as 5 feet. The actual measurement is 4.5 feet. So he measured it, which is going to be his approximate value. This is your approximate value. Okay, the actual measurement is 4.5 feet. This is your exact. Okay, what is his percent? So same formula here, we're going to do our approximate of 5 minus the exact, which is 4.5, over the exact, and then multiply that times 100. Again, if I plug this in my calculator, 5 minus 4.5 divided by 4.5, multiply that times 100, I should get 11.1%. Okay, so again, the hardest part about these is making sure that you have labeled your variables correctly. Is really just making sure you've labeled your variables correctly, and it's confusing between A is approximate, E is exact. I just messed it up too. Okay, next section of the test. So these are your questions that look like questions you could potentially see on the IB exam. So we're going to go over these together. Okay, it says let T equal 11.2 times 10 to the 7th and Q equal 4.61 times 10 to the 5th. It says write T down in correct scientific notation. When we're looking at T, we've got 11.2 times 10 to the 7th. Reminder, in scientific notation, we can only have one number to the left of the decimal. Here we have two numbers to the left of the decimal. Okay, so we want to make sure that we're moving this dot or this decimal point one more to the left so that we have 1.12 times 10. If we've moved this one more to the left, we have to add 1 to our exponent because that's another space we've moved. So this becomes times 10 to the 8th. Okay? So when we move our decimal place once more, we've got to add 1 to our exponent as well. Now this says calculate t divided by q. Okay, so we're going to divide this by this. So t is 11.2 times 10 to the 7th. Q is 4.61 times 10 to the 5th. And I'm going to plug that right in my calculator. It's really, really important that you set up the fraction bar first. So 11.2 times 10 to the power of 7, 4.61 times 10 to the power of 5, and I get 242.95. Okay. This last one asks you to write your answer to part B in correct scientific notation. So I'm going to rewrite my answer. My decimal point is right here, so I'm going to move it 1, 2 spaces to the left. So I've got 2.4295 times 10. This is a really, really big number, so my exponent is positive. It's 2 because I moved 1, 2 spaces. And that would be my correct scientific notation. Okay. Now this next section, we're using 2 new values. Got A is equal to 4.1 and B is equal to 3.5. It says find the exact value of 3A plus B squared. Here, I'm just going to plug in my values. So I know that A is 4.1, so I'm going to plug in 4.1 for A. I know B is 3.5, so I'm going to plug in 3.5 for B. When you plug it into your calculator, make sure you are using those parentheses to keep order of operations correct. So when I plug that into my calculator, I should get 3 times 4.1 plus 3.5 squared. That gives me 24.55. Okay. It said Kim estimates that the answer to part 1 is 25. So this is her approximate guess, because it's a guess. Okay. What is the error made by, oops, it should say, that's a typo, by Kim in her estimation? Okay, so this is our approximate value. We just calculated this as our exact value. So reminder that our formula is our approximate minus our exact when we're just calculating the error. This isn't percent error, it's just error. So this is the only formula we need. So our approximate is 25. Our exact is 24.55. So 25 minus 24.55 gives me 0.45. That is my number error. What we're going to do next, it says what is the percent error, which is a very, very similar formula. Our approximate minus our exact over our exact times 100. Okay? We've already calculated this piece, right? It was 4.5, or 0.45, excuse me. So I'm just going to use that from before. So I've got 0.45 over our exact value, which was 24.55, times 100. So that's going to give me, again, set up your fraction bar, 0.45 over 24.55 times 100. That gives me a percent error of 1.83%. So only a little bit of error on that one. Okay, one more of these style questions, 2 ACT questions, and then we are done. Okay, so on this one, it says a cubic container has sides that are 2.7 meters long. So we're going to look at, that means the length, the height, and the width are all 2.7. Find the volume. Remember, volume is equal to length times width times height. So I'm going to multiply 2.7 times 2.7 times 2.7 to find my volume. 2.7 times 2.7 times 2.7. So I'm going to plug that into my calculator. And that should give me 19.683 meters cubed is my unit for volume. Okay. Next, it asked me to give my answer in part A in centimeters cubed. So I need my unit conversion chart. I'm going from meters to centimeters here. So I'm going to set up what I'm given first, which is what I just found. I'm given 19.683 meters cubed over 1. So that means meters cubed has to go on the bottom. Centimeters cubed has to go on the top. Of these two, centimeters is my smaller unit. So I'm going to look at my chart again, and I'm going to see that there are 100 centimeters in 1 meter. So there are 100 centimeters in 1 meter. So from there, I've gotten to my centimeters cubed. I can cancel out the top and the bottom with that meters cubed, and I'm just going to multiply straight across. 19.683 times 100 gives me 1,968.3 centimeters cubed. Okay? Now, it says decide whether 4,000 liters of water can be poured into a container. Justify your answer. And this should say milliliters here. So I know that centimeters cubed equals 1 milliliter. So the first thing that I'm going to do is rewrite this as 1968.3 milliliters. Because I know I can compare milliliters and liters. Okay? So what I'm going to do next, I need to compare this to liters. So what I want to do is convert milliliters to liters. So again, I'm going to start with what I'm given over 1. 68.3 milliliters over 1. And I need to convert milliliters to liters. So then I set this up, milliliters on the bottom, liters on the top. Going to look at my conversion sheet here. I'm going from milliliters to liters. So there are 1,000 milliliters in 1 liter. So if I'm looking here, there are 1,000 milliliters in 1 liter. So I'm going to now multiply this out. I've got 1968.3 over 1,000. I'm going to divide this. Got set up my fraction bar first. 1968.3 over 1,000. And that gives me 1.9683 liters. Okay? Now, it's asking if 4,000 liters can be poured into this container that is only 1.9683 liters. This amount of liters is much smaller than 4,000 liters. So no, that amount of water will not fit in the container. Because 4,000 liters cannot fit in almost 2 liters. All right, very last two are practice ACT problems. Both have to do with scientific notation. This first one here, my decimal point is right here. I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, till there's only one number to the left of the decimal point. So that gives me 8.73 times 10 to the power of 11. But this is a really, really, really tiny number. So our exponent has to be negative. So my answer here is B. On this one, I'm just going to plug this into my calculator exactly as it's shown. And I've got 6, 7, 0, 3 more zeros, 3 more zeros, plus 7, 2 zeros, 3 zeros, 3 more zeros. And that gives me this big number here, 137 with 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. I know my decimal point is on the right because this is a really, really big number. So I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. So there is just one number to the left of the decimal. So I have 1.37 times 10 to the 9th. And because this was a really, really big number, my exponent stays positive. So my answer is D. And that should be it for our quiz corrections.